Welcome back. We're still in Lesson 5, students. This is video 5E. Today's topic, there are a lot of definitions that go with this lesson. We're working on sampling techniques, and so we need to get the definitions down. What I'd like to do, I'll bring every definition back to the Cecil College physical education building example. So remember from a couple videos ago, at Cecil College, money was spent to fix up the gym. The question is, are students using it? And the question we're asking students, do you regularly use the phys ed building for any purpose besides normally scheduled classes? Okay, so we'll go through the definitions, and every time we'll bring it back to this example. First definition is a census. You've probably heard of the census before. It's a sample consisting of the entire population. Now, in general, in statistics, we don't need to take a census. To take a census is a lot of time. To take a census costs a lot of money. And with just a sample of the population, just a piece, we can usually make good decisions. So, at Cecil College, what would a census be? Somehow, some way, and I don't know how we would do it, but survey all 2,500 plus Cecil College students. I cannot even imagine how you would ever get a hold of all 2,500 plus Cecil College students to ask them whether or not they're using the gym. Okay, but a census would be, we'd have to get everybody. Clearly, to get a sense of are students using the gym, we really don't have to talk to everybody. So we'll go on to sampling. Okay. Next definition. What's a sampling frame? Get this out of the way. Sampling frame, the definition is it's a list of individuals from which the sample is drawn. So for this example, registration probably has a list of every student that attends here at Cecil College, but as a statistics instructor, they're not going to give me that list. That's private information. I don't think published anywhere on the internet is a list of every student that attends Cecil College. If we could get it, that's what a sampling frame would be. A frame would be a list of every Cecil College student. Now, does this list exist? It does over registration. Could anybody really get their hands on it to collect a sample from? The answer is probably not. Okay. Many times when we're doing sampling, to get a hold of a good sampling frame is actually a very difficult task. Think about if you were going to go to Walmart and sample Walmart customers and determine how much they're purchasing. There's no list that exists of every person that's going to go to Walmart tomorrow, right? If businesses want to investigate their customers, they might have a customer list. That would be a sampling frame. If we took a MAT127 class and looked at all of the students that are there, and we consider that our population, then I have a sampling frame then, because every student's present there in front of me, and I could draw the sample from those students that are present. Okay, but again, that's just a list of every Cecil College students, and this would be nearly impossible for us to get. All right, so 2 done. Maybe 10 more to go. Here we go. Next up, simple random sample. This is the gold standard of sampling. In fact, I'll write that down here up in the corner. This is the gold standard. Almost every statistical method starts with assume you have a simple random sample. Okay. This is the gold standard, but it's very hard to achieve in practice. Let me read what we have here. It's a sample drawn such that every sample has an equal chance of being selected when put against every other possible sample, and also every member of the population has an equal chance of getting picked. Okay? In essence, it's like drawing names out of a hat. So we can sort of simplify this formal definition. A lot of times a simple random sample is sort of like a lottery. Put the ping pong balls into I don't even know what it's called, that thing you see on the TV when they draw the lottery numbers, and numbers pop up. In this day and age, simple random samples, typically we would have a list of students or our population in a computer, and we would use a computer program to randomly select members of that population. But the idea is this: it's drawing names out of a hat. Now, for the Cecil College, are you using the gym example? I want to show you how difficult this would actually be. Okay, these are hard to do in practice. Step one, we'd have to number every student. So the first student would get number 1, the second student would get number 2, so on, and then the 2500th student would get number 2500, all the way down the line. Step 1, number students. 1, 2, blah, 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 up to 2500, up to 2501, and so on. Okay, everybody gets a unique number. Once we've numbered the students, I don't think I'm putting these on slips of paper and drawing them out of a hat. I'd probably use a computer program to randomly pick. So step 2, typically use, it's called a random number generator. Doesn't come up too much in this class, but in case you ever hear this. Use a random number generator to pick. I'm thinking back to 2 videos ago, maybe we taped that a week ago. I think we picked 200 students in our example. I sure hope we did. So use the random number generator to pick the 200 students. Everybody has an equal chance of getting picked. Every possible sample of 200 is as equally likely as every other possible sample. Okay? This is the best way to draw a sample. But in practice, can you imagine doing this at Cecil College? Say student number 117 is picked. Now we need to go find that student. If we email that student, do you think they're going to reply to the email? If we try to track them down on campus, are they going to want to talk to us? So there's lots of issues that we'll always have to deal with when collecting data. Crux of the story, simple random sample. Again, it's like a lottery. It's like drawing names out of a hat. And officially, this is how we would do it. All right. Well, if simple random's the gold standard, there are other ways to take samples. We'll start to look at those right now. First up on our list of about 5 or 6 different sampling methods is what's called a stratified sample. Okay, so here's a stratified sample. Sampling design in which the population is divided into subpopulations or groups first, and then we'll take random samples from each of those groups. Or we'd call them strata, comes from stratified, right? The groups here are called strata. We're picking students from, well, all the students at Cecil College, and here's the example I came up with. I looked it up on the computer. At Cecil College, about 62% of students are female. So let's tie this back to Cecil College. At Cecil College, we're 62% female. I guess that'll leave 38% to be male. Okay. Now we're thinking about the gym. If I took a true simple random sample, could you imagine for my 200 students that possibly through luck, I might not get a mix that's exactly 62 female, 38% male. I could have a lot more females just by the draw of the names by the computer. But if this is important to me in my sample, if it's important to have 62% female, and why might it be important? Well, we don't want to short shrift the guys here. Males might have completely different needs and wants in the physical education facility than females, right? The typical exercises and programs for females might differ widely from what males might want in a gym. So if I want my sample to make sure that it's 6238, we'll do stratified. Okay, so I take my students, I'm going to pick 200. Sample size totals 200. What I will do is I will make sure that I have 62% of 200 to be female. So how many females would that be? Looks like 144 females. And that'll leave the rest to be males. It's going to be what, about 66? Somehow we got up to 210 people here. Oh, what is this? Mistake here, 62%, 124 females, pardon me. And the rest here would be 76 males. Good thing we caught that. We don't want to have to retake this whole video, right? Here's our 200, we'll force it. Females, males, this is 62%, this is 76%. And basically just take a simple random sample. Take your females, let's do a simple random sample. Here, and again, I'll abbreviate it as, occasionally you'll see SRS, simple random sample. Okay, so that would be stratified. One final comment on stratified, don't just do this to do it. You need a reason to do it. If it's important that our male-female balance is precisely what it is at the college when we sample, then stratifying is a good way to ensure that that happens. All right. Clusters next, I bet. I hope I'm right. All right, good for me. Another way to take a sample, cluster sample. A sampling design in which entire groups are chosen at random, usually done as a matter of convenience or practicality. Okay? Groups must be heterogeneous, and what that means is that each group mimics the population. Bring this back to Cecil College example. Again, we're trying to get that sample of students to determine who uses the gym and who doesn't. So cluster sample here. What I can do is I can look at individual classes. If you go to the schedule book, we've got tons of English classes, tons of math classes, tons of science classes, history, computers, etc. Okay? As long as we're willing to say that, you know what, if I took a statistics class, shouldn't the students in the statistics class sort of have the same gym habits as the general population? Probably. If I went to a typical English class, would the students in an English class have the same gym habits as the general population? Probably. Okay? As long as we can say that the groups must be heterogeneous, each group mimics the population, take a look at individual classes, and maybe we'll randomly select. Randomly select, oh, say 20 classes. These are called the clusters. I'm breaking up my population into groups. The groups are called clusters. And once the classes are picked, we just show up and whoever's there that day are part of the sample. Right? All students present. All students present are in the sample. All right, you can see a cluster sample. This is done as a matter of convenience, but as long as we're willing to say that, you know what, a typical English class will mimic the population, then this is a perfectly fine way to collect data. You've got to be careful though. If you looked at, say, a yoga class might not be a good class to show up in our cluster because I'm guessing students taking yoga might a higher percentage might use the gym than the general population. So be careful when using this method. You do need this requirement that each group mimics the population. All right. Next one, there's a few more methods to sample. This one's called systematic. Let's see what this one says. A sample that's drawn by taking every kth individual. So what on earth does that mean? At Cecil College, we probably don't have a list of all 2,500 students that attend here, so I won't be able to look at my list and draw a simple random sample. But, during the week, students are parking in the parking lot and funneling into their classes. One way to take a sample that will help randomize and help keep the sample unbiased is to do what's called a systematic sample. For instance, every 10th person that I see coming down from the top parking lot will be part of my sample. And the idea is that by taking every 10th person, that should randomize, that should mix up the students that get selected. Okay? So for the Cecil example, one way to do this, I'm not saying this is the only way, but we can stand, right, we can stand in the top parking lot. Take, for instance, every 10th student. When you don't have a frame, this is a great way to collect a random sample, a semi-random sample. Think about the Walmart customers. If we're a consumer group, we'd like to understand how much people are spending at Walmart. We certainly don't have a frame of the customers. I could stand in the parking lot at Walmart and take every 15th person that leaves and ask them how much that they just spent. Okay? So systematic. The list is getting longer. We've had simple, random, stratified, cluster, systematic. I think there's another one. Let's see what we've got here. Yep, convenient sample. Almost done with this list. Convenient sample, a sample that is drawn by selecting the most readily available data without implementing randomization or any of these official methods that we've been going over. Okay? So, by the way, convenient samples happen all the time in the real world. The one danger is that these are often biased. So we've got to use caution if we just start collecting the most convenient data that we could get our hands on. If I bring this back to Cecil College, here, administrators, administrators go to the TC building around noon. And basically just go door to door collecting data, right? Visit classes in the TC building. It's convenient for them. They're collecting the data. They said, well, it's around lunchtime. I'll go check out the 12 to 2 classes here. Administrators go to TC building around noon and essentially just walk door to door. They haven't used any official methods. This is certainly not a simple random sample. This is not a cluster sample. This is not a stratified sample. This is not a systematic sample. It's convenient. You will get your data. But without putting all that thought into how are you going to get the data before you actually go collect it, there's a good chance that this data is biased, that this data collected wouldn't represent the whole college when it comes to gym habits. All right. Wrapping this up, I know it's a long video, bear with me, we'll get there. Multi-stage sample. Any sample that combines the things that we've covered. So at times you just won't do a cluster sample. You'll first cluster, and then after you cluster, maybe you'll do a stratified sample. When you start combining methods, it's multi-stage. I came up with a good one in my notes, so I'm going to reference that. Again, we're still collecting students. whether or not they use the gym. So the first thing I will do is I will stratify by, well, main campus here and Elkton Station. I have a feeling that the gym habits of students that attend main campus might be different than Elkton Station. We don't want to forget about the folks at Elkton Station. So, I don't know the actual breakdown. I'm just going to throw some nice round numbers. I'm going to make sure that I get 90% of my data from the students on main campus, and I'm going to get 10% of my data from the students that just go to Elkton Station. I don't know if that's even close to the breakdown, but it's my best guess, and these are nice sounding numbers. Now that I've stratified, I will cluster by class. So what I'll do, I'm going to pick 18 classes on main campus and sample those. Every student that's present in the 18 randomly selected classes will be part of the sample. To keep this 90-10 percentage breakdown, I guess that means I'm going to sample 2 classes at random from Elkton Station. Okay? And every student present there will be part of the sample. Now, when it's all said and done, depending on the number of students, it might not be perfectly 90-10, but we're combining methods, so we've got multi-stage. All right, a few things can go wrong. We've got to cover that briefly, and then we'll finally get to push the stop button and move on to a new video lesson. But before we tape this one, I knew it was going to be a long one, so hang with me, students. A few things can go wrong. Non-response bias. Bias introduced into the sample when a large percentage of those picked fail to participate. Cecil example. Let's bring this back to our gym example. Suppose we decide to collect our data through email. Suppose that we email our selected students. Maybe we did a simple random sample. Maybe we did a cluster, or who knows what. But suppose we email our selected students, ask them to comment on, do you use the gym or don't you? Do you think I will get 100% response rate? Probably not. 100% response? No way. If students got that email and they read it and they've decided not to respond, then I don't know what the response rate would be if I had to guess. Maybe 10% respond? I'm not sure. We've never done this before. It'd be interesting to see who responds and who doesn't. But that's non-response bias. Why you need to think about this is the people who are willing to respond might feel differently than the people who just blow this off. So if that happens, then really you have 2 groups and you're missing out on a lot of opinions that might differ from the data that you do get. Okay, so that's called non-response bias. 2 more to go. What else can happen? Undercoverage. If you're collecting data, we need to think about these things. Undercoverage is another one. A sampling scheme that biases, since it gives part of the population less representation than it really has. Undercoverage. Okay, so we're still drawing everything to Cecil here. All right, I thought of something. Suppose we do a systematic sample in the parking lot. I like to keep banker's hours, so I don't want to get up too early or stay here too late. So I will show up. I mean, I'll put in a 5-day week here. I'll show up every day. But, you know, I'm kind of like roll out of bed around 10, like to get out of here about 3 o'clock. And so I'll do a systematic sample in the parking lot, first week of school. I'll come up Monday, Tuesday, Wednesday, Thursday, Friday. I'll put in a good 5 hours every day. Is there any undercoverage? In other words, are there Cecil students that can't even be part of the population? Right? Are we missing people? We're giving them less representation than they should get. So the answer is, of course. Who are we missing? Well, I bet there are tons of students that aren't up here at this exact time, right? So to make this easy to write on the slide, can I just call those night students? I'm going to run out of room, but I suppose those would just take 8 o'clock in the morning classes too, right? They can't be really picked. We have weekend students only, I'm sure. Who else are we missing? I bet some students just take online only. I bet some students just go to Elkton Station only. And I've run out of room, but I'm sure if we put some thought, there are others that we're missing, right? The night students, the very early morning students. Maybe a student was, well, out of town this week, or they didn't take classes that week, right? Weekend, online only, Elkton only. Undercoverage. These students have no chance to even be part of the sample. If they're different than the ones that are in the sample, then we'll have a biased sample. It won't represent the population. Last but not least, I promise, if you flip the page, there's nothing more here. We're done. Voluntary response bias. Bias introduced. Individuals can choose on their own whether to participate. Back to Cecil College. What if I put a survey on my Cecil? So here, put a survey on my Cecil. Oh heck, social media too. We'll put it on our Facebook page for the college. And whatever else Cecil College is putting out there these days, Twitter, etc. Okay, we'll put a survey. We'll ask students, hey, do you use the gym for reasons besides taking classes? Who's going to respond? Typically, people very interested in using the gym or very against using the gym, right? It sort of polarizes the results. They have to feel passionately to take the time to respond, right? This is called voluntary response bias. If you're responding to the My Cecil survey, then you probably really enjoy the gym. You want to get your 2 cents in the survey. If you could care less or really are sort of neutral on it, and this isn't exactly a very heated argument here to use the gym or not, but you can imagine on news sites and things like that, who's responding is people who feel very passionately about the government shutting down, for example. So you'll get voluntary response bias. Okay, we need to be aware of these problems. Every time we collect data, different types of biases can creep in and sort of influence the results. Remember the main point. We're collecting a sample, which is just a piece of the population, and we want that piece to represent the whole pie, right? So we want to take a good sample using an official method, and we always need to be aware of biases that can creep in and sort of make the sample not look like the population on average, okay? So thanks for hanging in there. I know this was a long one, but we'll see you again real soon.